Okay, so in this problem, I have a graphic designer, Ben, who wants to create an animation in which a sequence of squares is created by a composition of successive enlargements and translations, and then rotated about the origin and reduced in size. So here's the outline of the storyboard. So he's going to start with a square, then shrink it down and shift it, shrink it down and shift it, and so on. Once it's sorted, then he's going to start to rotate it. So the first 4 frames of the animation are shown in greater detail, as shown here. And then the sides of each square, are 1/2 the size of the adjacent largest square. Let the sequence of squares, just the squares, be 0, 1, 0, U1, sorry, U0, U1, U2. The first square has a side length of 4. So I want to find an expression for UN. Well, if U0 equals 4, U1, it's going to be half the size, is going to be 2, U2 is going to be 1, and so on. So if I recognize it's shrinking, so my general form is going to be UN 4 times 1/2. If this is 0, then I get 4. If it's 1, I get 2. And so I can see that this exponent is going to purely just be n. Okay, so here's the first part. Moving to the next part, it then says, Ben decides the animation will continue as long as the width of the square is greater than the width of a pixel. Given the width of a pixel is this much. So I want to go 4 to the 1/2 to the n. I want it to know when it is going to be equal to 0.025. And so if I solve for this, I get 1/2 to the n is equal to 0.025 over 4. And I can graph this, or I can use logarithms and say log to the 1/2, the base 1/2 of 0.025 over 4 is equal to n. I get my n value to be 7.321. Now, if I read this carefully, I will continue as long as the width of the square is greater than the width of the 1 pixel. So if I round this to 8, the square is going to be less than a pixel. So I'm going to shift this down and say n is equal to 7. Okay, so now Ben, he decides to generate the squares using this transformation, where AN is a matrix for the enlargement, and BN is the column vector that represents the translation. X0, Y0 is the initial point for U0, every point in there, and XN, YN are its image. So I want to write down A1. Well, it's going to be the enlargement matrix, and so if I look here, what's happening, it's this particular square going to this square size, that enlargement, and I know it's by 1/2. And so A1 is simply going to be 1/2, 0, 0, 1/2. And AN is going to be subsequent matrices, so it's all going to be 1/2 to the power of n, 0, 0, 1/2 to the power of n. And when I go to D part, by considering the case where x0, y0, 0, 0, state the coordinates x1, y1 of its image. Well, if we go back to the diagram, it's asking, where does 0, 0 go? Well, 0, 0 on this square is in this corner, which is 4, 4. So x1, y1 is going to be 4, 4. And so B1 has to be, well, if I know that I can say that A1 times 0, 0 plus B1 is equal to 4, 4. Well, this is 0 plus B1, which is 4, 4, which means the vector B1 is equal to just 4, 4. That's the translation vector. We get 4, 4. show that Bn is this particular scenario? Well, if I consider, I know B1 is 4, 4. B2, if I look at my diagram here, so 4, 4, it's going to shrink down by 2 and it goes up here. It's going to end up being 6, 6. And then this one here is going to be 7, 7 because it goes half all the time. So it's 4 plus 2 plus 1 is what's happening here on this one. And this is going to be plus a half and so on and so forth. So I recognize that this is going to be, B2 is going to be 2, 2. B3 is going to be 1, 1. And so on. And so I recognize Bn is equal to 4 plus 2 plus 1 and a 4 plus 2 plus 1. Well, if I just think about the 4 plus 2 plus 1 plus, this is a geometric sequence. And so I take U1 and I go, my U1 is equal to 4, BR is equal to 1 half. And so I can go 4, 1 minus 1 half to the power of n over 1 minus 1 half. And so that's going to be 4, 1 minus 1 over 2 to the n over 1 half, which is equal to 8, 1 plus 1 over 2 to the n, which I believe is what I'm supposed to try. Oh, almost there. Oh, and I magically turn my minuses into a plus. So this is minus, minus. Minus, minus, which is equal to 8 times 1, 2 to the minus n. And so Bn is simply 8, 1 minus 2 to the minus n, 8, 1 minus 2 to the minus n. So if I want to find the coordinates of the top left-hand corner of U7, well, I know my x, y, n is equal to 1 half to the power of n, 0, 0, 1 half to the n times x0, y0 plus 8, 1 minus 2 to the negative n, 8, 1 minus 2 to the minus n. Well, I want n to equal to 7. And so when I plug in x7, y7, it'll be 1 over 2 to the 7th, 0, 0, 1 over 2 to the 7th times, well, I have looking for the top left-hand corner value, which is going to be x is 0, y is 4, plus 8, 1 minus 2 to the minus 7, and 8, 1 minus 2 to the minus 7. And if I throw this all into my calculator, I will end up with the point 7.9375 and 7.9687. Okay, as we continue on here, once the image of squares have been produced, Ben wants to continue the image, or rotating the image counterclockwise about the origin, and then having its size reduced during the rotation. Let E theta be the enlargement matrix used when the original sequence of squares has been rotated through theta degrees. Ben describes the enlargement scale factor as should be a linear function with a function of theta. And after a rotation of 360 degrees, the sequence of squares should be half its original length. And it's going to find the form of this. If it is a form of a line, that means I need 2 points. My 2 points could be, well, when theta is 0, my enlargement is 1. my second point will be when theta is 360, my enlargement is 1/2, as I want it to be half the original length when it's 360. From these 2 points, I can find the slope. I do the change in x minus a change in delta y, which is 1 minus 1/2 over 0 minus 360, which if I do this computation ends up being -1 over 720. And so then I know I want y equals mx plus b. I can also know that this is going to be my y-intercept. And so s theta is equal to -1 over 720 theta plus 1. This is going to be my scale factor as a function of theta. Hence, write down E theta. Well, my enlargement matrix then, E theta. This here is my scale factor. So it ends up being negative theta over 720 plus 1, 0, 0, negative theta over 720 plus 1. That's my enlargement factor matrix. Hence, find the image of 1, 1 after it's rotated 135 and then enlarged. Well, if I'm going to take my point 1, 1, I'm going to rotate it and then I'm going to enlarge it in that order. So 1, 1, my rotation matrix of 135 degrees using is cosine 135, sine 135. Let me tidy that up a bit. Okay. It's going to be, and I'll actually move over here, so cosine 135. Using my formula book, this is sine 135, sine 135, and cosine 135. And then the enlargement is going to be this particular matrix, but it's going to be 135 over 720 plus 1, 0, 0, and a minus 135 over 720 plus 1. When I multiply that all out with care, I get negative 1.15, comma 0 is where that one ends up. So hence the image of 1, 1 after it's rotated 135. This is the matrix that rotates it, and an enlargement by this particular matrix, which was defined here, we end up with negative 1.15 and 0. Okay, so continuing along now, it wants to say find theta, which the enlargement scale factor equals 0. So if I consider this is my scale factor here, negative theta over 720 plus 1, and I want this scale factor to be 0. If that's the case, I know 1 is equal to theta over 720, and so theta equals 720. So when theta is 720 degrees, the whole entire scale factor is 0, so basically becomes non-existent. But then it keeps on going after that. If we keep on reading the question now, after the enlargement scale factor equals 0, so it's gone through, theta's gone through 2 revolutions of the circle. Ben continues to rotate the image for another 2 revolutions. Describe the animation for these 2 revolutions, stating the final position of the sequence of squares. Well, so basically it's theta starts at 720 and then it's going to go 2 more revolutions, so it's going to go plus 720 more. So describe the animation. Well, the first thing that's going to happen is it is going to rotate counterclockwise, because I know it's still going to go theta is going to go 720 degrees, and so it is still going to rotate around the circle, right? So it's going to rotate counterclockwise. Now the second thing that's going to happen is that the enlargement matrix is going to start to get large again. So as this starts to grow, it's going to start to, enlargement matrix it will grow and the squares get larger. Squares get larger. But, here's an important but, they're going to get larger because if this is over 720, this value is going to be negative. It's going to be a negative value, which means that it will be either rotated 180 degrees or reflected over the origin. Those are the same thing. Over the origin means the same thing. So because it's enlarging a negative value, if it was over here, it's going to actually end up over on this side. And so I know it wants the final thing it wants to say, stating the final position. Okay, if I just want to state the final position, what happens is that final position, the initial position, the squares were here, and let's say it's at a 45-degree angle. Well, after it's gone through a 720 plus another 720, which is 4 full revolutions, the theta is still going to be in this position. However, what happens then is it's been reflected about the origin, so it ends up actually being over in the third quadrant. And so it ends up fully reflected over the origin, and the origin in the third quadrant. That is a big long question. I hope that helps.